Great. Come to the stream for today. Today will be a very fantastic day. We will do some nice MCP server hacking. We have done this last time already, but today we will actually do this again. But now, today we'll use some Rust and we will do some real cool stuff with the MCP or with the Model Context Protocol. If you hear some phone ringing in the background, sorry for that. I'm currently on call, so stream could abruptly end, but let's see. So yeah, let's start actually. And hello also in the chat. I read the chat not continuously, but I try to have an eye on that. So if you write something, happy to involve you as well. So let's quickly jump into what we want to do today. So here we go. The plan for today is actually doing something here with an API client. And last stream, I already talked a little bit about the Model Context Protocol. So if you go to Model Context Protocol IO, I don't repeat everything here. Feel free to just watch the stream from last time. Interestingly, while stream seems to work well, the internet on my laptop is not that good. Let's see how this works out. Good. So Model Context Protocol, very simple thing. You can give basically an agent, like your coding agent, like Claude Code, or also Claude Desktop, which is not a coding agent, but also some kind of an agent. And of course, also what we have used already here, the agent in the Z editor, for example, works also very well. Then there's cursor and other stuff. You can give all those things tools and prompts and other cool stuff, resources, and so on. So we went through this a little bit last time already. Don't want to go into details today. What we want to do today is actually the following idea. So the idea basically is that we have, let's change the colors here a little bit. So let's say we have here our agent, and we now want, we have here our API. Let's say we are an API company, or we are doing whatever we want. Well, let's say you're working at Blue Sky and you want to provide an API, or you provide already an API. In Blue Sky case, it's probably in PDS that has an API, and you want to show actually this API, or make this API accessible by the agent. So what we want is actually that the agent can use our API. So how to do that? Of course, the agent cannot do it itself because the agent actually doesn't know our API. Now we could use an agent that knows our API. We could build our own agent, of course, but all of this is not really scalable. So the scalable solution here is obviously to go through something in between. And that something in between is actually our MCP server. And the MCP server will allow us to, well, the agent can use the MCP server, and then the MCP server can actually work like a proxy on our API. So it might work as a proxy. Let me quickly open the door here for the dog. Looks like he is waiting something outside. Good. So that's basically the idea. We have the agent, we have the MCP server, and we have the API that we want to access. Now the point is, what we want to do is we don't want to build, well, that's actually not the idea behind it. So you can just build your own MCP server for whatever API you want to build it. That's not the big deal. Think of it more or less like a proxy. What we want to do instead is actually not just build an MCP server that can access your API, but that can access basically every API. So what is the idea behind that? You know, probably tools like Postman, for example. And what Postman basically does is it gives you a way to configure your endpoints and your requests and all the stuff you can do on your API. You can even create collections of different endpoints that you want to call in a specific order. And you can even share this with others. And or you can import this from Open API specs. And the cool thing is you can use that through the user interface to do requests against your API. And this can be used even by people who are not familiar with a command line and not familiar with using a tool like curl. So why not doing something similar with our agent? So what if we build an MCP server that can use some similar kind of data than we have in Postman, let's say. So we could basically write a little importer, import our Open API spec, import it to some data format that works with our MCP server. Well, maybe the MCP server could use it directly also from the Open API spec, I don't know. But it gets some information here that it can use actually to provide endpoints, and it can then offer the agent a tool to actually see what endpoints are available, what is the documentation for each endpoint, and then we can interact with our MCP, with our agent actually, telling the agent, hey, make a request to this endpoint, or we can even give it more or better instructions. You know, we could also give it some rules and tell it, oh, if I ask you to log in to my API, then please perform the following requests against my API to do the authorization here to get an access token, and use that access token that you get actually in upcoming requests. Of course, we can go all the way down to also let the MCP server manage environments and other stuff. So think of this like like a Postman application, but not designed for humans, but designed for agents. And that's actually the idea that we want to work on today. So of course, we will not have a finalized product here at the end of the day. That's too unrealistic. But what we have today and where we are starting with is I prepared a little bit here, the Cozy API project. I did this actually on, I prepared this on the weekend a little bit. So let me give you a quick overview what this is. So this is a Tauri application. Tauri is a framework that you can use to build desktop applications for all platforms, Linux, macOS, Windows. And it uses web technologies. I've done some streams with Tauri already in the past, and it's still the same good Tauri framework. And what I have set up here is there's a little TypeScript application. I use here Solid.js. If you want to understand why, there has been a stream already about Solid.js and why I think Solid.js is a very good choice for doing some desktop application with Tauri. So this is currently just a Hello World application, so nothing that really is important here, just to make it work. And we will probably not do a lot of TypeScript hacking today. Let's see how much we will get there on the user interface side. The focus today first is definitely on the MCP server. So the other part of the Tauri application is actually some Rust code that launches the application. And you find the Rust code usually in a source-Tauri directory. I moved this actually into crates because I want not just one crate. Actually, so in Node.js applications, you will probably have a directory called packages, and then you have different modules of your application in there in your monorepo. In Rust, you usually call this not packages, but crates, because that's how you call things in Rust. And here we have a Cozy API crate, and that actually contains our Tauri application. So there's a Tauri conf.json file. That's actually what is important for the Tauri file, for the Tauri application. You have some icons here and some source code. Here's a main.rs file in it where actually the application starts. So in my case, I have built a little CLI around my Tauri application, so I can start the application as usual, but I also can actually start the MCP server. We can quickly look into that. Quickly look into that. So the run function basically is a clap CLI here, and what it basically does is it chooses either to start the MCP server, or by default it will just run my Tauri desktop application, which then launches a web view and launches the Solid.js application in this web view. As I said, today we are mainly focused on this this MCP server. So let's quickly look into that MCP server. So as I said last time already, there are different MCP SDKs already available. And every day when I look on this page, there's a new one. So today the Ruby SDK pops up here. This wasn't there yesterday when I remember correctly. There's also one for Java, Python, Kotlin, Swift, TypeScript, and so on. You don't see one for Rust. Let's quickly go on the Python one. So you don't see one for Rust, but the point is you don't see one for Rust yet. The reason for that is that well, there is a Rust SDK, but it is still in development. It's not fully released yet, so that's why they don't put it on the web page. But as you see, the web page is continuously updated. There is some work currently being done on the Rust SDK, so it's really work in progress. And if you look into that, you can also see here some examples how to work with that SDK, and yeah, you can already build something with it. It depends basically on Tokyo, which is, well, not very surprising, and it uses actually JSON, because the MCP protocol is nothing else than JSON RPC done through some transport, and yeah, that's basically it. So we have an SDK for Rust. We have the model context protocol. The important thing we want to work with is actually the tools. And that's also the one that is supported by most clients currently. So we want to provide tools to actually interact with an API. So let's quickly look into how this will look like. And if we leave this thing a little bit aside, let's say we are having our MCP server here. And there is, of course, we are doing this differently. So what we have is we have our API here, we have our agent here, and we have our MCP server here. So that's the basic idea. What's the problem is actually, how does our MCP server know what endpoints exist? And also, how does it know what environments exist? If you look at something like Postman, you not just have endpoints that you can configure there. What you also have in Postman, for example, is you have environments that you can configure to have specific variables being set. So, for example, you can have an access token, and you can have, let's say, a different domain for your testing environment or your sandbox environment compared to your production environment. So you want different endpoints or different your domains actually for the different environments. You want probably access tokens being configured there, or client credentials that are hopefully different. You shouldn't use the same client credentials. Or you should not have the same client credentials for your sandbox and your production environment. That's a bad idea, of course. And so you want those kind of things as well. Probably nothing we will build today, but that is actually the idea what this MCP server should in the end do. So what we need to make this possible is we kind of need something that the MCP server can actually access to have some data in it. Let's call it let's call it a store. And of course, we need something to actually fill in the store. So there might be another component. I don't know. Let's say a UI. And let's take this UI component to fill something into the store. So the idea would be that the UI can be used to create endpoints, to create other stuff, and it will store these in the store here, and then the MCP server, whenever it is invoked here. So this is actually a tool use or tool invocation, actually. I'm not 100% sure how this is called. Tool use. Let's call it a tool use. So when the agent uses a tool of the MCP server needs to look up in the store, actually, what endpoint configuration is provided there. So, and what environment is configured here and so on. So that's being used here. And then the proxy, and then it can actually perform the actual HTTP request. So this is no longer going like a proxy. It is probably more like, it is more like execute requests. So that's actually the scenario that we want to go for. What is the right choice for such a store? I don't know. There are plenty of options. In my opinion, one of the nicest ones is SQLite. There are several good reasons. One of them is that Tauri, we want to build the UI with Solid.js and Tauri, so that's basically TypeScript. And Tauri has a nice plugin to provide SQL into your web view. And SQLite is supported there as well. So your TypeScript code in the web view can access a SQLite database. That's very nice. And also the MCP server, although it's not written in TypeScript, it will be written in Rust. It could just use the SQLX library to access the SQLite database. Basically, the Tauri framework uses SQLX as well, so we are not putting multiple embedded SQLite databases here. And the cool thing about SQLite is you don't need a server. You just have it embedded as a library into your application. So you just ship it as a library with your binaries. And in the end, it's just a single file. And this file is very backwards compatible. One of the big features of SQLite is that these database files are backwards compatible. And this means that you don't have to upgrade the database when you upgrade the version of your library. And you don't have to care about that in any way. So this means that there can be a database that has been created 5 years ago, and you might be using SQLite in a new version, and you just open it. You just open this old file, and you just work with it. It's that simple. So there's nothing bad to be expected here, like version breaks or other stuff that can actually be a problem. And if you want to ship an application to the user's computer or the user's device, using a database that can just upgrade without big issues because of backwards compatibility is definitely a benefit. That's really something worth it. And you really want that to avoid any issues with upgrading databases, reverting this, whatever, downgrading. You're probably not using the most experienced, or your users might not be the most experienced people in using actually an SQLite database or a database like this. And so you're doing them a favor if the database just works. So that's actually the idea. Let's store some data in an SQLite database. Let's use it from the MCP server and then tell the agent or give the agent a tool that it can call to actually perform some requests. Good idea. Let's see how far we get with that today. Maybe not everything of that, but let's start somewhere. So as I said, I have prepared already some of the parts. but not all of them. I think one that I missed actually, yeah, I see. One that I missed actually is to provide here proper config. And I think that's not the right place. So, come on. Let's first get into coding mode actually. Let's see. I hope you can actually read the text on the screen. I tried to make it big enough. Let's maybe increase the font a little bit. Is the buffer font size? Let's increase this. Now, give this a try. So the point here is that what we actually want is we want the database tier to be configured. And the question is, what do we want to set this to? And I have to actually look this up. So the Tauri app, or Tauri actually provides some way to get this. They call this an app config, where by default all the here. That works great. So configure. No clue where they have hidden it. But we can just ask. So does default. Let's see what Cloud has to say about that. Thinking. Here we go. Yeah, that's actually what I was looking for. So in Rust, we can use the app data dir. That's what we will go. No, the data dir. That's not correct. It is not the data dir. It's actually the config dir. But it should be pretty much in the same place. So let's just copy this one. That it is the config here. Let's see if this code already compiles. Nice. Looks like there is something. That's the interesting question is, returns the path to the user's config here. That's something to implement better later. Let's start just with actually the relevant part, which is this one here. So on Linux, it goes into .config in my home directory. So let's just go and hard code it. I will not solve it now. We want to do something better here today than solving this. So let's just hard code it to config that cozy API, and then we have the database name. So that's the DB name. This. Then we can just pass it to and we can actually so now we have the config actually being hard coded. But at least this will work. So if we now open the terminal and run here application and development mode, what will happen is, well, this code will first compile, of course, and we are waiting for a few seconds, and we will see that the database has been created, and it will even have a table being created, to be honest. We will see this in a second. So let's quickly reload this. So you see actually the broken user interface here. That's because there is no user interface here. But what we can see actually is we can open it. So now there's a data DB, but I called it cozy API DB. Why is this? I know why this is. Okay, I called this data DB. And I didn't use it. So in the, no, not in the MCP server, but in the Tauri application, I also have to use it, otherwise it will not work. So what we do here is we just, now how do we do that in? So let's quickly ask doing that. Is the DB name data DB? Let's see if it gets this done. Okay. I think that's acceptable. Of course, we need to make this available. And then we just do it like that. So yeah, okay, that's fine. Let's do it like that. So now we have passed it here and in the MCP. So we have to do something similar here. Oh, we don't use it here yet. So let's ignore it for a second. So now if we run the CLI, we should also have done that. Okay. So let's run the application once again. Because it would initialize the database again. It's in this, it's still there. So what we can do is actually select star. And get nothing because there is nothing. But the table at least exists, so that's already fine. So the cool thing on SQLite is also that there's this simple SQLite 3 command line tool that you have in basically every Linux distribution on Mac OS. You can probably install it via Homebrew, and you can just look into the database. You know, that's a nice thing. It is an SQLite. It is an SQL database in the end. So very nice way to store your data. Okay, so now we have fixed this database location. Let's go into the server here. So what the run function in the MCP, so here we are now in this MCP server crate. And what the run function here does is it starts a server and it then basically waits until the server is done. And that's all it needs to do. So whenever the client stops the connection to the server, it can just go down and that's it. So let's quickly go into the new function because that's probably what we are looking for. So that's defined here. So we have this struct, which is a server, and then within the server we have the create. No, we have the new function to create a new server, and we can then also add and we can then define tools here. So you see already a little bit the Rust SDK for MCP servers being in place here. So one thing is actually we implement the server handler trait from the RMCP SDK. And the server handler trait provides basically all the different methods to call actually the MCP protocol. And the one that we implemented here is just this get info. So the get info function is part of the MCP protocol. We spent in the last stream quite some time on implementing this in a wrong way. But in the meantime, I learned actually in the Rust SDK, it's quite easy to do. You have just the server info here. And then with the server info, well, you can provide actually how it's being called. You can provide some instructions. Well, this is probably not a very sufficient instruction. We could provide a much better one. But then you can also tell what capabilities you want to enable. For example, the tools capability needs to be enabled to provide tools. And if you enable the tool capability, there are other functions that you can actually implement for from the server handler that allow you to list resources or get a resource or get a prompt, for example. But for tools, what you do basically is you enable them. And then you implement different asynchronous functions here for your struct, for your server in this case. And for example, this add function here, that's of course nothing we will keep. That's just a dummy function. But there is this add function, and you just put this tool with description on it to tell actually the Rust SDK that this function here is a tool. And then the SDK will just expose this function as a tool to the MCP client. And we can also see this see this working. So if we go, here for, if we don't run the application, but the MCP server in development mode, what you can see is that it will launch the Model Context Protocol Inspector. We have seen the Model Context Protocol Inspector already last stream. What it does is basically providing a nice way to look into your application. So here we have selected the transport type stdio. Our command is cargo with the arguments run MCP. That's nothing really fancy, but it works. So if we call here the connect, we see some logs here being printed. That's because we are compiling the code, obviously. And then when we look here, we have actually the history that is called here. So it's actually connected to our MCP server. It made the initialize request, and it returns actually the server info here and the instructions. So basically the things that we've just seen here in the get info function. So basically on the initialize request from the MCP client, the server will actually return the data coming from the get info. So no, not this one, but this one. So that's actually what happens. So what we can do here is we can now do, because we see tools here being enabled because we have enabled tools. So if we want to provide prompts, for example, we have to call enable prompts on the initial capabilities. We can see this here. We have only, so capabilities contains logging and tools. And so no prompts, no resources. So this means only tools are available, and you see this here in the interface. We can call, if we have tools, there are two things that you can do. First, you can list all the tools, and then you can use a tool. So if we list all the tools, then you see there's only one tool. It's called add, and we see this. It's a function called add being defined here. So now we can just call this, or select this actually, and we can, for example, add A and B here as numbers, and if we run the tool, we will see the result, which is 3. So we can also see the request being made here. So the tools list request was made, and the response returned just one tool, which is named add, has a description and an input schema to accept here two properties, A and B, of format int32. And it requires both of them. Here's some schema definition. And yeah, that's it. So it describes basically what the tool accepts. And then we have here the tools call request with the name of the tool that we want to call. The arguments, of course, they have to meet the requirements of the schema. And I don't know what this progress token actually is, but it will have some some value, I hope. And we get a response, which is a content. It is not an error, and it returns a type of text with the number 3. So if we go back, this returns a string. We could maybe change this also to some numerical value, and then we get a different type here. But there's no need to do that right now. So so that's basically what we have. That's all we have. A tool that adds numbers, and that's it. So what we want is, of course, another tool. And our new tool should, what should it actually do? It should make a request. So we would expect that it, very nice. So we would call an endpoint. So do we want to call it? Oh, that's actually a good question. Let's call it, well, request. Let's just call the tool request for the moment. We can still change it later. And what will be the input? I don't know. Let's not have an input for the moment. And what will be the result? Some result. No, not really a result. Let's remove that one. And let's just say we return, oh yeah, sorry, we need this one. And we just return a string. I don't know if string is a proper result here, but let's start with that. We can still change this later, of course. So the string would now be, for the moment, something like hello world, toString. Sounds good. So now we can actually request it. And let's also send a greeting. Come on. Make an API request. So, and obviously this is no longer valid. So now let's go here and restart it. We see it takes a moment. That's to be expected because we are having a tool being implemented in Rust. It requires a moment to be compiled. So we see it's still compiling, and now it's connected actually. So here we go. Let's clear the tool list. Let's list the tools again. We see a request tool. So we can say make an API request and it returns hello world. Well, great. So we called an API actually. A very fancy API, as you can see. Yeah, but at least it works. Of course, that's what we wanted to see. So let's continue from here. So the first thing that we want to do is we want to have an endpoint that we can call. So where do we get this endpoint from? Currently, this is neat. So currently we don't have actually something like an endpoint. We don't need this to be poly. So what we want is a struct that is do this in a better way. Here we go. To the request tool. to the request tool. Use the endpoint. To query the before we do that, let's add the SQLite here. Let's add the um, let's actually add the database first. Sorry, I didn't do that yet. So let's go into create MCP server. Go add SQLX. I did this already in the past, so let's quickly add this. So this one add SQLX, which is a very, very nice tool in Rust to deal with databases of all kinds. And what we want to do is we want to, in the new function, we want to create a new pool. So how to do that? Let's start with, so the that as to save db to the server to the as database. The SQLite. So SQL let's do looks like that Claude 1 right here. I have the impression that Claude 4 is really something very good compared to Claude 3.7. So at least I have the impression that there's some kind of improvement compared to the previous version. So I'm really happy about using it right now. But yeah, let's see. So it provides us some work here. If you haven't tried that, that's new agent mode. Um, that's a pretty good one. I really enjoy it compared to other options. I really think it's. Um, I tried others and I always come back to this one. In the end, it worked best for me yet. So the others are not as good as the one here. The only one I like as well is Claude Code. Um, but um, but still, I think that has a little bit better agent most of the time. Sometimes Claude Code is better, but I really enjoy it. I'm currently waiting for also Ada getting MCP support because Ada is also quite a nice one, and I would like to compare it as well. But here we are now with that, and yeah, let's see what it's doing actually. Key features, yay! So it looks like it's done. Great. So let's quickly go through the key features. And it explains a little bit what it did. Changes made. First, update the server. So it added the database. Modified the constructor. Well, surprise. Updated the run function to create actually the connection, to create actually the pool. Well, we didn't tell it where to look actually for the database, so it connected to something. That's, let's say, at least disappointing. Um, and then, well, it's not disappointing. We just didn't tell it. That's how it is. Not very intelligent, this AI. So it enhanced the request function. And we didn't ask it to enhance it. We just asked it to, I don't know, to make it accessible. But well, it even used it. Wonderful. Great. So, and the key features, SQLite connection pool, in-memory database. Well, that's not a feature that we are looking for, but let it be. Database is currently configured as in memory. You can change the connection string to use a file-based database via SQLite database DB. That's nice. We will do that. And the SQLX dependency was added, was already present with the correct features. Yeah, I know. We added it before. All database operations are async and should probably handle. Okay. Connection pool is automatically managed by SQLX. Yeah, I know. Great. So let's quickly review the code that it created. So here we go. We have the SQLite connect. So let's quickly look into this documentation. There's not really something useful here. So it uses this. Well, it is how it is. It creates a new server with the database now. It now uses the SQLite pool in the server, passes it through, and well, the tool actually, what is it doing? It returns database connection successful. Okay, if we can query a select one. Okay, nice. Let's keep it all. Let's do it the vibe coding way. And let's see what we can do with it. So when we go back to the MCP inspector, let's restart our MCP server. So what we should see now, it's compiling again. Of course, it's compiling again. So let's wait until compilation. So we just have to wait a second, you know, so, well, not 1 second. It's a Rust compiler. We have to wait for a moment until this has been restarted. So here we go. It finished dev profile unoptimized, which is totally fine. We don't want to wait longer. And here we go. We have list tools. We can make a request and we can run the tool, and the database connection is successful. Well, that was an easy one because we're using this in-memory database. That's not really what we want to do. What we want to do is we want to, it even gave us instructions, didn't it? We want to use this here with a database file. So let's do that. Let's say we want to use this from the config. So to make the config accessible, and then we use the format. Exactly. Database URL would be too nice, but that's not config db deal config db. Just do this. Something is still so now we have passed the connection here. And of course we can make this db this and here we go. There's wonderful, nice little details that drive you crazy with Rust when you use it for the first time. Luckily, I've run into this issue several times already in my life, so yeah, that's yeah one of those things where you realize that Rust is a low-level um, language that is used for building things without a garbage collector, so you have to care about how things are handled in memory. And here we go. Okay, we now have the database URL being passed here. So we can now look into the MCP server. So now, come on. What do we want to do in the MCP server? We don't want to do the select one. What we want to do is we want to carry the in the request function, to make the request to. The to the endpoint table created in DB. This be? I think it was here. Didn't it work? We did in DB. And it's from the note to the endpoint table created in DB. So, column name to that table without creating very early we can do that. We can just delete our database and then create it again. So that should be fun. Use the name to query. Also add a column name to that table without creating a new migration. The name is unique string. Okay, that's nice. In the request function, use a name argument to use the name argument to query the endpoint, the database, and HTTP using the so, first things first, we are still in the MCP server and is, um, maybe we could even tell it, but the problem is by default it adds it itself to the it just modifies the cargo toml file, which is not what I want. I wanted actually to call cargo add instead, but I probably have to set up some rules for that. But yeah, let's do that later. And now a very important detail. I also could put this into a rule, of course. Make all SQL lowercase. I don't know why LLMs tend to make SQL uppercase, but if you don't tell it, they will not do it. So where are we? Running thought process. In the meantime, we can also just remove our database. Mainly because we have to recreate it because of modification of an existing migration. So before migrations break, we'll just remove it. Also very nice that you can just delete a file and that's dropping the complete database. I'm not sure if this is really good, but it works. Yeah. One of the interesting things, by the way, since we are waiting here for a second, one of the interesting things of SQLite is also that if you use SQLite to store the data of all your API endpoints, you can share it within the team. Of course, it would be even better if there is some way to synchronize this in a proper way, but you could easily share this by just copy this database file and provide it to your colleague. That's working. You can just copy the database over. That's just working. Of course, there's limitations of that approach. You cannot copy the database file and then two people are modifying the database at the same or in parallel. And then you want to merge this. Well, that's not going to work. But if you can deal with that, a very simple way of copying the database file to someone else and share it with someone else is there. You can do that with limitations, but you can do that without any additional service or anything like that. If this whole approach works out, of course, this tool, this open source project will probably get also a sync and collaboration SaaS product behind it. That would be awesome. But for the moment, let's see if this works out at all. This is an experiment. Let's see if we can build this. Let's see if we can actually figure out how to really well tell an LLM to use this tool in a proper way and then really do some effective work with it. Because one thing is using or writing a tool, another thing is making this good. And like usability, there is also something like usability for LLMs. An LLM doesn't automatically work well with your tool, so we have to deal with that and experiment with that once we have built it. So here we go. It is still editing and editing and editing, telling me about the key features. It's very talky right now, which is quite interesting. Summary. I successfully implemented all the requested changes, database schema changes, updated the endpoints table. Yeah, I know. Now has a name, which is unique. Okay. And we have the endpoint struct, which has all these different values. Yeah, I actually created that and updated at obviously timestamps, but we will ignore them. That's not really relevant right now. So then the enhanced request function does what? It accepts a name parameter using the tool param attribute. So this is actually how it does this, like adding the tool itself to the function. We call this a tool param to expose this actually as a param. Then we fetch the endpoint from the query, do some other things. Okay. Yeah. Here it makes a lot of assumptions about what it finds in the database. That is maybe not that, I don't know. We would probably have a better mapping than this. But for the moment, it is how it is, you know. We can just do it like that. We can improve it later, make it work first, improve it later. So now we have the database integration. We use the request to make the HTTP request. This is happening here. No, endpoint method. Here. Client get, client post, client put. As I said, I'm not sure if this is the right way to do that. But it is how it is. So we make an HTTP request on the endpoint's path, which is nice because where do we configure this client actually? We just give it new. So this will probably not work, obviously, because the client doesn't know what domain it should make the request to. But that's how it is. Let's fix this in a second. Okay. All SQL queries use lowercase as requested. Really? Let's double check. Select from endpoints where name is equal to that one. Okay, cool. And we're binding the name. Nice. Yeah, looks good. Let's quickly have a look into the code. Yes. Yeah. So what we do is the application once, mainly to trigger the database creation and the database migrations. So creation and migration of the database will work now. So the application started, the database has been created. So the restart the server. database file exists. Maybe we restart the resource server. Again. What's wrong? Integrate database pool. It doesn't find the database file. I did find it here. DataDB. We just opened it here. So we think before. Dog wants to come back. So we the file being created doesn't. It is exactly the same database file. Wonderful. Don't know why it's failing. So what could be the reason for this file not to be opened? Let's try to remove it once again. Let's again. Let's try the file again exists. That's great. It worked before. It does. That's the best ones. And the weird thing is we didn't really change anything that could impact this here in the last change. So we just changed all kind of other things, but not how we actually use the database. Only thing that we changed is the database migration, but who cares? That's not really the thing. That doesn't make any sense. I don't like these kind of errors, as you can expect. Okay. I think this is something to fix afterwards. And I will probably not really make this. So let's fix this in a different way. So let's make this an option of a SQLite pool. And then in the CLI, no, not in the CLI, in the librs, we just pass in just not use that. Good. So we don't use the database right now. We will skip this. We want to actually perform a real query, a request to an HTTP server. That's more important um, than getting this working. So what we want is actually, we want an endpoint. We don't have a new function here. We want an endpoint, some string. Nice thing. So let's related to running it in this. No, I can't go at UUD. this greeting endpoint. Also fine. We use the method, which is get. Fine with that one. We use path, which is greetings. Also fine with that one. And we have, let's just use 25. And now we have the updated event agreement. So we don't need this actually, but that's fine. So we now have an endpoint. You know, we could have fetched this endpoint from the database, but you know, we don't have it. Now we want to create a client, and the question is, retain the retain. So I guess what would happen is if we return a result here for a string and some error, then the error could actually contain the name must be greetings, and then we would get a result of type that is saying is error true. You know, we have seen this before in the model context protocol inspector. Just as a side note, that might be the way it works. I didn't try it out yet, so something to do in the next stream maybe. But this should be good enough. So now we have yeah, this endpoint actually, you know, this check here and this endpoint here, that should actually be done from the SQL database, but we have to fix this first, but not today. So we want to do this working. So now the next thing that is missing is at the base URL HTTP the because currently we just provide the endpoint's path, but the path is just slash something, and this is not having a full domain. So the HTTP request will go somewhere, actually nowhere. They will just fail. They cannot just do I don't know, maybe request has some magic here to perform this on localhost port 80 or something like that. But I don't expect this to work like that. So now this looks better. Great. So yes, it adds the pause here. So let's just keep it all. Okay. It could also have been that the client accepts somehow a base domain. I don't know. Didn't investigate this. So let's just take it as it is. We might improve this anyway at a later point. So now we have the responses and the response body will be, and the status will be returned. Yeah, exactly. So this is great. So what are we missing? Well, what we are missing is a very, very tiny thing. We don't have an API. So let's fix this part as well. Let's get an API actually. And the way we are doing this is just creating one. Don't need any specific Python, so just UV init. So we'll create a simple Python API with fast API, nothing very special. We'll just create this and use it to serve some HTTP requests. Actually, we just need a greetings endpoint, you know, and we'll just use that for mocking here our service. Of course, we are in a Rust application. We could also use Rust and Axum here for creating a dummy server. But Python is for vibe coding a quick solution here, much easier to do. One of the reasons is LLMs are pretty good at writing Python code, and Python doesn't have the same complexity that LLMs struggle with as Rust. Most of the time it works, but sometimes they actually struggle a lot with Rust code. So let's keep things simple. Let's just do some Python stuff here. We call this we do this in a subdirectory. Let's call this the dummy API. So here we go. In the dummy API, we have a main. Go code here. In the create a simple API with greetings /greeting using fast API. The oh, so we provide the MCP RS file here as well because it is actually being the client. So it provides additional context here. And that might be useful, you know, that might be useful for it. To run this API, you need to install fast API and vcorn if they are not already installed. Yeah, well, great. That's true, but we are not using txt. Um, oh, um, UV at go. It's a fast API. We found it's open for all use. It's not exactly what we need. We just need localhost. But let's go for that. That's fine for the moment. It's just for testing purpose. So let's UV. Let's just fix this stupid one quickly because I didn't think of it. There's still something. I think yeah, the missing import might come from being here in a subdirectory. I think the LSP is not very good at dealing with that. But doesn't matter. It's just we would probably create a dummy or a test server in Rust instead later. I just want to get this running actually. So here we go. We have now the server. Let's run a curl on it. HTTP localhost. No, we don't. We even don't return that one. Let's just call the greetings endpoint. Okay, it returns some JSON. Of course it does. So JQ. Here we go. So we have some nice. It's not exactly what we wanted, but it is fine. Um, so now let's go to our client. We have now the client. Actually, this should already work, isn't it? So let's give it a try. Let's connect to this server. Let's see where this is going. It is connected. It is. Yeah. We stopped it running. So we want to run the MCP server. Let's wait a second. Here we go. Let's connect it. Database fears never. Yeah, don't care. let's run the application once. See if it still doesn't compile. The interesting question is this: how do we not find out here? Let's go to the inspector layer. And now it's connected. Okay, nice. So I don't know what went wrong, but it looks like now it's connected. So let's once again list the tools. We have a make request. We can provide a name. It should be greetings. And if we run the tool, we get a tool call, and the tool call returns status 200. Oh, we can also scroll down here. Status 200, okay. Body, message, hello from Cozy API. Wow, that's pretty nice. So now we could actually make this look nicer, of course. The interesting question is, what is the right format to provide here? And one thing I have in mind is to let this output look like an HTTP request response cycle in HTTP1. So if you look at HTTP1, it is a text-based format. So what happens actually is that there is a string line by line sent over a TCP connection, and the response is coming the same way back. Of course, the body is not line by line. It could also be multiple lines. But basically, you get the headers and all the stuff. This is line by line sent through the TCP connection. So this could also be just locked here exactly like that. So there is a very specific header or a set of headers coming from the HTTP server. That could be one way to do that. Could also be a different format. In the end, it's important that the LLMs understand the result in a good way, and that all the information is provided that they need. I don't know. Let's see. But I think HTTP request and response could be a way to do that. Of course, non-text bodies need to be handled somehow. But yeah, let's see. Yeah, this is actually it for today, because the missing part, so what I really would like to have here is that we also fetch the greetings endpoint from the database. But that's how it is. So this is a very, very first step to make an HTTP request from the through the MCP protocol, and yeah, this is actually to be continued. So we kicked it off. Now let's make it work in a proper way, and that's it for today. So enjoy your time. See you next time, and I hope you enjoyed it. So, till the next time. Bye, everyone.